Hello dear friends, welcome to the lecture of ordinary differential equations. We are studying differential equations of first order and first degree. In this lecture we shall solve some problems on exact differential equations. I have written a few problems here. We shall first solve these one by one and then I shall give you some problems for practice. First we shall revise what is the exact differential equation and what is necessary and sufficient condition for an equation to be exact. So this we have proved in our last lecture. And a differential equation of the type m dx plus n dy is equal to 0 is exact if and only if this that is a necessary and sufficient condition if and only if we have dou m by dou y, partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So this is the condition, and if this condition is satisfied, then the solution is given by integral. I am writing this again for our reference, or we are using this rule, working rule, to solve the equations, and the solution is given by integral m into dx. Here y is constant plus integral terms of n not containing x. So this we have written in our last lecture into dy is equal to c. So this is the working rule, or this gives directly the solution. Now we consider the solution of the first problem. Solution 1. See, this equation is in the form m dx plus n into dy is equal to 0. See, this is the value of m and this is the value of n. So comparing the given equation with m dx plus n dy is equal to 0, we get the values of m and n. Comparing the given differential equation with we get the value of m is the coefficient of dx, and that is y into 1 plus 1 upon x plus cos y. This much is m, and n is x log x minus x sin y. This much is n. So we shall check first that dou m by dou y is equal to dou n by dou x or not, and that is the necessary condition. So we have partial derivative of m with respect to y, and that is, see, when we differentiate partially with respect to y, x is to be treated as constant, and 1 is constant, this x is constant, means this expression is constant. 1 plus 1 upon x is constant. Derivative of y is 1, so it is only 1 plus 1 by x. And what is derivative of cos y? This much is the derivative of the first term partially with respect to y, and derivative of cos y with respect to y is negative sin y. So this is dou m by dou y, and what is partial derivative of n with respect to x? So that is to be remembered. For m we differentiate partially with respect to y, and for n we differentiate partially with respect to x. Now here we shall have to use the product rule, because both the terms are of x, function of x into log x. So first function x, derivative of log x is 1 upon x, and then log x as it is, derivative of x is 1. That is plus log x. So this much is the derivative of the first term. And then what about the derivative of the next term? Minus x sin y. Sin y is constant and derivative of minus x is minus 1. So minus sin y. And you see what is the expression. So we should see as this is 1 plus log x minus sin y, and that must be here x plus log x. We have to correct this. This must be x plus log x. So it is x plus log x minus x sin x. This must be the expression. So and then now this becomes, I shall write below, then dou n by dou x is, so this is n is x plus log x minus x sin y, and now dou n by dou y. Dou n by dou x means partial derivative of x with respect n with respect to x. See, it is the derivative of x is 1 plus derivative of log x is 1 upon x and minus derivative of x sin y is that is sin y, minus sin y. And now we observe that this dou m by dou y, partial derivative of m with respect to y, is equal to the partial derivative of n with respect to x. So this condition is satisfied, and therefore thus dou m by dou y is equal to dou n by dou x, and the given equation is exact. That means the original equation, this is exact. Now its solution is given by, or directly the solution is integral m dx. Y is constant. We are writing again the same rule. Integral m dx, y is constant, plus integral terms of n not containing x into dy is equal to c. Terms of n not containing x into dy is equal to c. So this is the solution is given by this rule, and now it is easy to express the terms, and then after integration we will get the solution. So this is integral, what is m? See, m is this much, here it is m. M is this expression, y into 1 plus 1 upon x plus cos y into dy into dx, you see, into dx, plus terms of n not containing x, integral, and what is the expression for n? This is the expression for n. And what are the terms of n not containing x? See, this term contains x, this term contains x, this term also contains x. So there is no term of n which contains does not contain x, and therefore this will be 0, and thus it is 0 into dy is equal to c. And now you see the expression for this, and this is to be integrated with respect to x, treating y as constant, and therefore the integration of this one will be see, y is constant, so y will be the same. Integration of 1, we shall write directly, integration of 1 is x, and plus integration of 1 over x is log x, this cos y is constant, and integration of 1 dx, 1 will remain there, into dx is x. So this much is the integration, and integration of 0 is 0, plus 0 is equal to c, or that means this is x into cos y and this is xy. So x into bracket we can write y plus cos y, and this x I have taken common, y plus cos y, y plus cos y, and then y log x is equal to c. This is the solution. This is the general solution. Now we shall consider the solution of the second problem. The second problem is solve this expression, you see, and again comparing the given differential equation with m dx plus n into dy is equal to 0, we get, what is the value of m? M will be y square into e to the power xy square and plus 4x cube. This much is m, and n is 2xy e to the power xy square, x into y square minus 3y square. So these are the values of m and n. Now we shall check the condition, dou m by dou y is equal to dou n by dou x or not. So this must be satisfied, then only we can use this method. So we have dou m by dou y, partial derivative of m with respect to y. Now to get the partial derivative of m with respect to y, we treat x as constant and use the same formula and the rules of differentiation. So here x is constant and this is function of y, this is also function of y. So we must have to use the product rule of derivative. So first function y square, first function as it is, derivative of e to the power x into y square. Again that is e to the power x into y square into derivative of the exponent by chain rule. That is x into y square partially with respect to y, and x is constant, so it is constant as it is, and derivative of y square is 2xy, derivative of y square is 2y. So this much is the first term, keeping y square as it is and writing derivative. So this much is the derivative of e to the power xy square, plus the remaining term in the product rule is derivative of y square, that is 2y, and this function as it is e to the power xy square. So actually this much is the derivative of the first term with respect to y, partial derivative with respect to y. And what about the partial derivative of the second term? X is constant, so therefore that is 0. So this is the partial derivative of m with respect to y. And now we shall consider the partial derivative of n with respect to x. And further, and dou n by dou x is equal to, here we have to differentiate partially with respect to x, so therefore y is to be treated as constant, and that means 2y is constant. So I shall write 2y separate, and this function x into e to the power xy square is to be differentiated partially with respect to x using product rule. So first function, that is x, 2y we have written outside. First function, derivative of e to the power xy square, that is e to the power xy square into derivative of xy square with respect to x, and y is to be treated as constant, means y square is constant, derivative of x is 1, so into y square, and that is the first term, plus now what is the second term? Derivative of x, that is 1, and this term as it is e to the power xy square. So this much is the derivative of the first term, this term. And now what about the remaining term? This is a term of y. We are differentiating with respect to partially with respect to x, and therefore this is constant, its derivative is 0. So this is the partial derivative of n with respect to x. Now we have to check whether these two are the same or not. Now for that purpose, you see, if you take 2y common from this above expression, then what remains in bracket is x into y square e power xy square. We are not simplified, we are observing directly. And then again, if we take 2y common, then what remains in bracket is e to the power xy square. So therefore these two are equal. You can easily verify this. Or you should simplify one more step here, taking 2y common, or this term also can be taken common, exponential term can be taken common. But we see these are equal. We see that partial derivative of m with respect to y is equal to partial derivative of n with respect to x, and therefore the equation, given equation is exact. The given D is exact. Its solution is given by this working rule. Is given by. We should write the rule so that we have to remember this. So integral m dx, remember the condition, remember the form of the exact differential equation, and the steps are fixed. Y is constant plus integral terms of n not containing x into dy is equal to c. Same I have written. And now we shall write the value of m. What is m? I shall write one step here, that is integral m. M is having this expression y square into e to the power xy square plus 4x cube into dx plus integral terms of n not containing x. You see, this term contains x. One term is, here it is x, and that means the entire expression, the first term contains x, and therefore we have to delete it. And what is about this term? This term does not contain x, and that is minus 3y square only. That is minus 3y square into dy is equal to constant. And here we have to remember y is to be treated as constant with while we integrate with respect to x, and that gives. Now see the integration of the first integral. So that is integration y square is constant, so we have to write the integration of this term only, and that will be y square integration of e power xy square. Integration derivative of exponential function e to the power x is the same, or actually the integration of e raised to power ax is e to the power ax divided by a, coefficient of x, and that means we have to divide by coefficient of x, that is y square. So this much is the integration of e to the power xy square with respect to x. So the formula of integration are important. Without knowing the formula and methods of integration, we cannot solve the differential equations. So therefore you should revise the formula of integration. All the important formulae must be remembered. And this is the integration of first term, and the second term is easy, 4x cube plus 4 integration of x cube using power function formula, integration of x power n, x to the power n plus 1, that is 3 plus 1, which is 4, divided by the same 4. So this much is the integral of the first, and this is simple again. Minus 3 is constant. Integral of y square is y cube divided by 3 and is equal to constant. So that can be simplified. You see, it is simple. Y square divides out, and it remains e to the power x into y square plus x to the power 4 minus 3 cancels, also divides out, and minus y cube is equal to constant. So this is the general solution, and this completes the solution of second problem. Now we shall solve the third problem. Again, comparing the given differential equation with this m dx plus n dy, we get, or see the third problem. Third problem is x into dx plus y into dy plus x dy minus y dx divided by x square plus y square, and that is equal to 0. Here we shall observe that this is exact. X dx plus y dx, first two terms are exact, means they can be easily directly integrated. We can integrate x dx separately and integral of y dy, and this term also we can express in the form of total differential. So we shall do in that way, and you can try it by the same way of comparison by this method. So I shall solve the third problem in a different way, so that by inspection we can write the given expression, given integral in the form of exact differential, and the integration gives the solution. First two terms are exact differentials. First two terms of the given differential equation are exact differentials. And now what about this term? We will observe this differential. Also we have d of y over x, total differential of y upon x, and that can be written using the quotient rule or derivative of quotient, and we can write this is numerator differential of y, that is dy, minus, yes, this is the denominator first, the quotient rule, the derivative of u upon v, so that is v into du minus u into dv, etc. So this is x into differential of y minus y into differential of x, that is dx, divided by x square by quotient rule of derivative, by derivative of quotient. So thus this is the expression, and we may observe x dy minus y dx is this expression, and we can divide it by x square, and again we can multiply the numerator by x square, then that term can be adjusted. So making use of this result, we can write the given differential equation is, therefore the given differential equation can be written as so no change in the first two terms, that is x dx, that are x dx plus y dy, and next term I shall write in this form to make it total differential. This is plus x dy minus y dx divided by, so this is the same expression I have written, divided by, I shall write x square to make the expression here, but x square is not there, and so this term is to be multiplied by x square divided by x square plus y square and is equal to 0. You should note and check this. How we have written the same, but in place of this denominator I have written denominator x square. Why? Because this is total differential of y upon x by quotient, derivative of quotient. And then to make to remain the value as it is, we have multiplied the numerator by x square. So this divides out, and the denominator which is here, that is written as the denominator of the this term, second term. And see, the value must remain the same. So we have done only the adjustment of terms to write this as total differential of y upon x. Again, this is x dx plus y dy plus, so this is d of y upon x. So I shall write this as d of y upon x, and this term again I shall write in terms of y upon x, and for that purpose I divide the numerator and denominator by x square. If we divide the numerator and denominator by x square, the numerator becomes 1 and the denominators become 1 plus y upon x whole square. Dividing the denominator by x square, we have divided the numerator and denominator by x square is equal to 0. You note this, dividing the numerator and denominator by x square. Now why this is written so? Further, this is x dx plus y dy plus, and this I shall write at the numerator d of y upon x, and the denominator I shall write 1 plus y upon x whole square is equal to 0. Now you see, this is exact differential, d of y upon x divided by 1 plus y upon x whole square. So how it will be, if you write t in place of y upon x, then this becomes the form dt divided by 1 plus t square, and its integration we know it is a standard formula, that is tan inverse of t. Dt divided by 1 plus t, it can be integrated, and these two are also integrable. These are in exact differential form. This is also exact differential form, and thus in this solution we have made each term in exact form, exact differential form, and therefore this can be written as or now can be integrated. Integrating we get see what is integration of x into dx, that is easy, x square by 2 plus integration of y, that is y square by 2, and plus this we have seen, if you put this as t dt divided by 1 plus t square, that is integration of that is tan inverse t, and therefore here t is y upon x and is equal to a constant, that is c. So using the formula, since, or you may say as using formula of dt divided by 1 plus t square is equal to tan inverse t. This is actually the solution. This is the general solution. General solution of the third problem. Now I will suggest you to solve the third problem using this method, earlier method. If you use that method, then we must write this equation in this form, m dx plus n dy, and that can be written easily. You see, collect the terms of dx and then collect the terms of dy separately. So then that equation can be written as, so by usual method, alternative usual method. The given d is, I shall write in short, you should do that. If I consider this term dx and this term dx, then x minus y divided by x square plus y square into dx is the first expression of m into dx. Then collect the term of dy. Here is the term of dy, and here is the term of dy, that is y y, it is plus x divided by x square plus y square into dy is equal to 0. And you see, this is the value of m and this is the value of n. Differentiate this partially with respect to y and this with respect to x. Show these are equal and then use this working rule to find the solution. There may be the difference in this will be like this: x square plus y square, x square by 2, or that solution can be written as x square plus y square whole divided by 2 plus tan inverse of y upon x is equal to c. If you multiply by 2, then that will be x square plus y square plus 2 tan inverse of y upon x is equal to another constant. And see, this solution may be of the form x square plus y square divided by 2, and if there is a minus sign, then this will be tan inverse of x upon y is equal to c. See, this tan inverse of y upon x is same as negative tan inverse of x upon y. So that may be the change in the no, it is actually not change, it is the same. So the solution may be in this form, which is exactly same as this solution. So try by the usual method. Now these are some problems for practice. You should solve these problems. I have written the problems first, second and third. The answers are also written here. So you should solve the method that we have used for the earlier two examples, first and second. That means this method. First compare this with the m dx plus n dy. Write the value of m and n. You should note the sign also. It is n is minus of x plus y whole square. And then check the condition is satisfied, and after satisfying the condition, the solution is written in this form, and thus the answers are written here. So please try these problems yourself. Thank you.